Kit, Shiraj, Shiraj.
Present, sir.
Okay. Shivnanda, Shivnanda, Shraddha, Shraddha, Shubham,
Present,
Shubham.
sir. Present,
Okay,
sir.
right. Sumit, Sumit, Suraya Banu,
Present,
Suraya
sir.
Banu.
Present, sir.
Okay. Tejas, Tejas, Vivek, Vivek, Yamnappa, Yamnappa, गांवकर रजत रामचंद्र, गांवकर रजत रामचंद्र, मंजुनाथ, मंजुनाथ, प्रथमेश, प्रथमेश, जोसलिनो,
Present, sir.
जोसलिनो.
Present, sir.
Okay. So Ramesh is present. Ramesh and then Sadashiv Gari. Anybody else is present who joined late? I marked Ramesh and Sadashiv Gari. Okay. Let's begin with the class students. So we were discussing yesterday about the transistor switching network. It is inverter and a switch. Transistor works as an inverter and also as a switch. Right. Let us write the design equations for a transistor as a switch and as an inverter. The design equation is, let us design the circuit here. So what is the first one? First condition is, first case is, here the first condition we are applying. The first condition, that is when Vi equal to I. When Vi equal to I, Vi equal to V in or Vi equal to V volts, V volt, that time the transistor goes to saturation. We know that the transistor will go to saturation, correct? The transistor goes to saturation. So what will be VCE? VCE will be equal to VCE saturation. VCE saturation. VCE saturation. Right? VCE saturation, and IC will be equal to IC saturation. IC saturation. IC saturation. Right? So because the transistor will go to saturation when Vi is equal to V volt, so we have Vc is equal to Vc saturation and Ic is equal to Ic saturation. Okay. Then Ic sat, equation for Ic sat, Ic sat is given by the equation Ic sat is equal to VCC, VCC, the same equation as we have written for the saturation condition for the, that is emitter bias and that is voltage divider bias circuit, that is VCC minus VCE, VCE saturation, VCE saturation, this divided by, this divided by this divided by RC, this divided by RC. Okay, this is the equation here. This is the equation. VC C minus VC sat, that divided by RC, that divided by RC. Okay, by RC here. So if you look into this circuit here, so it is VCC, that is this voltage VCC minus VCE, minus collector to emitter voltage, that will give the voltage across resistance RC. So if we divide that voltage across resistance RC by resistance RC, then that will give us the saturation current, that is this current flowing through the collector terminal, saturation current. Is it not? So this is the one of the equations. Then the next equation is, here we have equation for output voltage. So equation for output voltage, V naught will be, that is VCE sat, because VCE is nothing but the output voltage. Look into this circuit, this VCE, collector to emitter, nothing but the output voltage, right? Because emitter terminal is grounded, so output voltage is nothing but the voltage at the collector or the VCE voltage. So that is also saturation voltage. VCE sat is equal to V naught. VCE sat is equal to V naught. So V naught is equal to VCE saturation. VCE saturation. Okay. So this is another equation. Then one more equation what we are supposed to write is for the input loop. Okay, for the input loop, if we consider this circuit, what is the equation here? V in minus IBRB minus VB is equal to 0. V in minus IBRB minus VBE is equal to 0. That is the equation for the input loop. Let us write that equation. V in or VI, V in minus VBE minus IBRB minus IBRB is equal to 0. Is equal to 0. Or let us write the equation for IB. IB will be equal to V in minus VBE, V in or VI minus VBE, VBE. Okay. If you take IBRB to the RHS, it will be plus IBRB. Therefore, IB will be equal to V in minus VBE, that divided by RB. That divided by RB. So this divided by RB. Okay. V in minus VBE, this divided by RB we have. Okay. So this one is divided by the resistance RB here. Okay. So IB is equal to V in minus VB divided by RB. Okay. This is one of the equations. Then here there is one condition. Okay. We know that IB max, if the current is saturated, then the base current will also be maximum. The base current is given by IB max or IB is equal to equation for base current or base current maximum. IB max is IC saturation, IC saturation, because we know that IC is equal to beta times IB, or IB is equal to IC by beta. So this divided by beta will give us the equation for the, that is IB max. So this divided by beta here, this divided by beta. Okay. This divided by beta, right? So this one is divided by beta here. This is divided by beta. Right? This is the equation for IB. Okay. So you all have to remember these equations. Then there is a condition here for the transistor to go to saturation. Condition is IB is taken equal to 120 to 150%, 120 to 150% of IB max. Okay, this is a condition for the transistor to go to saturation. IB should be equal to 120 to 150% of the maximum value of base current. Okay, if this condition is satisfied, then transistor will go to saturation. Transistor goes to saturation. Here, are you able to see this write out, students? Write up, you are able to see here typing. Yes, students, are you able to see here? Shiraj,
Yes, sir.
you are able to see, right? Shiraj, Chandrasekhar,
Yes, sir.
you are able to see here?
Yes, sir. Yes, sir.
Okay, fine. Okay, thank you. Okay, so this is the condition. Then similarly, resistance, saturation resistance, it is nothing but V by according to Ohm's law. Okay, that is transistor under saturation. This is equal to VCE saturation, VCE under saturation. This divided by, this is divided by the This is divided by the resistance, sorry, the current I. VC divided by the current IC saturation. This gives the resistance saturation. That is saturation resistance. IC saturation. Simple formulas. VC sat divided by IC sat, that will give us the R saturation. V is equal to IR, Ohm's law. Now, under the ideal condition, okay, ideal condition means the VCE sat, VCE saturation, this will be approximately equal to 0. This will be approximately equal to 0 under the ideal conditions here. Okay, approximately equal to 0. So if it is approximately equal to 0, then if you look into the equation for IC, the previous equation, what we have written here, see here, IC sat is equal to VCC minus VCE saturation by RC. But VCE saturation is 0 volts for ideal condition. Therefore, what will be IC saturation? VCC by RC. Because this VC saturation is 0 volts for ideal condition, that is non-practical condition. Okay, therefore IC saturation will be simply VCC by RC. That is IC saturation will be simply IC saturation will be simply VCC this divided by RC, this divided by RC, this divided by RC here. This is divided by RC. And if we look into this, VC is 0. Okay, just you look into this circuit here. That is what is the output voltage or what is VCE? VCE is 0 volts or collector voltage is 0 volts, correct? For the V in is equal to V, it is inverter circuit. Okay, if V in is equal to V, output is equal to 0, inverter circuit, not gate, right? So as VC is equal to 0 here, therefore what we will get here, as VC is equal to 0. Okay, so that is why when VC is approximately 0, what will be VC? VC is 0 here. So as VCE is 0, therefore RC saturation will also be equal to 0. Because VC is 0, 0 divided by IC, that will give 0 ohms. Okay, that is why it is shorted here. It is shorted here. Zero resistance when the switch is short circuit, zero resistance when the switch is open circuit, infinite resistance. Remember this. When it is short circuit, we have zero resistance. When it is open circuit, there is infinite resistance. Following here. So it is zero resistance here. Whatever we are getting, that is 0. So this is for the condition when V in is equal to VI. Okay, or V in is equal to input voltage. Then for the second condition, we have next for the second condition, that is when second condition when it is Vi is equal to 0, when Vi is equal to 0, when Vi is equal to 0 volts here. Okay. So for this condition, when Vi is equal to 0 volts, right, what will be the collector current when Vi is equal to 0, that is this input voltage is 0. Look into this circuit here. That is second condition, second case, when V in equal to 0, the base current is 0, right, and only leakage current flows in the collector. Only leakage current flows through the collector terminal, into the collector terminal. Okay, because of this, the transistor will be in off state. Transistor will be in off state. So let us write it. When Vi is equal to 0, we have simply IC is equal to leakage current, that is IC, leakage current we have, and equation for VC will remain the same. That is VC is equal to VCE VCE cutoff it is, because the transistor is in off state, cutoff VC cutoff, this is equal to VCC minus ICR. Same equation as we have written previously. Instead of IC saturation, here we have ICEO, leakage current, ICEO into RC. Okay. This is one of the equations. Then R cutoff, similarly as we have written for R saturation previously, we can write the equation for R cutoff. R cutoff equation, R cutoff equation, resistance under cutoff condition. This is given by VCE cutoff, VCE cutoff, VCE cutoff, okay, VCE cutoff. This divided by VCE cutoff. This is divided by the value that is ICEO, leakage current, because leakage current is flowing into the collector terminal, ICEO. Now under ideal condition we have, so what is the ideal condition? Ideal condition is, it is non-practical condition. Ideal condition we have ICEO, this leakage current will be 0. Okay. It will be 0 amps. Okay. ICO is approximately 0 under ideal condition. Therefore, what will be R cutoff? What will be VCE cutoff here? VCE cutoff will be 0. Okay, VCE cutoff will be VCE only. ICO is 0. So if you substitute ICO is equal to 0 here, okay. So ICO is 0 in this previous equation. What we will get here? Yes, can anybody tell me? If you substitute ICEO is equal to 0 here, what we will get here? VCE cutoff. Yes. It's infinity, is it not? Infinity. But it will be infinity. VCE cutoff by 0. ICO is leakage current is 0. R is equal to VCE divided by 0. So anything divided by 0 is infinity. So here you get infinity. Okay. So it is infinity. Okay. Right. So it is infinity you are getting here. So as it is infinite resistance, what it means? Infinite resistance means open circuit. Yes or no? Infinite resistance means open circuit. So it is open circuit here. This is open circuit. Okay, this is open circuit. So switch is shown as open here. Switch is shown as open. Okay, it is open circuit, right? So therefore, when it is V in is equal to V, output is 0 volts. Then it is closed switch. It is closed switch. Okay. Then when V in is equal to 0 volts, V naught is equal to VCC. Okay. That is, it is open circuit. Switch is open. So this is how it works as an inverter and also as a switch. Is it clear? Clear here? Got the point here? All of you? Is it understood here? How it works as an inverter and a switch? Janvi, is it understood? Janvi? Janvi?
Yes, sir.
Clear, right? Equations are clear? Simple equations.
Yes, sir.
Okay, right. So let us take quickly one example here on this. Let's take one example. For the previous circuit, calculate RB. Note down this example. Simple problem it is. For the previous circuit, calculate RB that just saturates the transistor when Vi is equal to plus 5 volt. Given that RC is equal to 1 kilo ohm, beta equal to 100, VCC is equal to 5 volts, VC saturation is equal to 0.2 volts. VC saturation is equal to 0.2 volts. Note down this example quickly. Calculate RB that just saturates the transistor when Vi is equal to plus 5 volts. Given that RC is equal to 1 kilo ohm, beta equal to 100, VCC is equal to 5 volts, VC saturation is equal to 0.2 volts. So this example is asked for 5 marks in June July 2017 question paper. 5 marks example it is. Note down the example. Look into the question and try to understand it. So for the previous circuit, which is the previous circuit? This circuit. Okay, for the transistor circuit. For this circuit, okay, they have given the circuit. For this circuit, what they are saying, V in they have given. V in is how much? Plus 5 volts. Okay. RC value, this value they have given. RC, this value they have given. RC is given. Okay, 1 kilo ohm. Beta is given. Current gain it is 100. VCC is given. It is 5 volts. VC saturation is given, that is 0.2 volts. What they are saying, the transistor goes to saturation condition. So when transistor goes to saturation condition, we have to apply the equations for saturation condition so that we will get the value of RB. They have asked to calculate the value of RB when the transistor goes to saturation condition. Okay. So when the transistor goes to saturation condition means when it goes to saturation condition, when Vi is equal to V, the transistor goes to saturation condition. This is the circuit of transistor as a switch or a transistor as an inverter. Okay, then you have to use the equations of transistor as an inverter circuit. That is for the first condition. First condition is when the transistor goes to saturation. That case you have to use case A. Okay, so it is this particular case A. Let us pick up those equations and quickly calculate the values. So when it goes to saturation, what are the equations we have here? IC saturation is equal to VCC minus VC sat by RC. So how much is VCC, students? How much they are given? VCC, yes. What is the value of VCC they are given? 5 volt. 5 volt minus VC saturation. How much they are given? 0.2 volt. This divided by RC. This divided by RC. Okay. This is divided by RC. Right. So this is divided by RC here. What is the value of RC we have? RC value is also given. It is 1 kilo. 1 kilo. Look at how much is this? So 5 minus 0.2, that is 4.8 volts divided by 1K, you get 4.8 milliampere. Correct? 2.8 milliampere. We got the value of IC. Once we got the value of IC, then we can calculate the value of IB max. This is the equation for IB max. IC saturation, this divided by beta. IC saturation by beta. So IC saturation, how much we have got? 4.8 into 4.8 into 10 raised to minus 3 milliampere. Okay, 4.8 into 10 raised to minus 3. Minus 3 we have got here. This is divided by, okay, this is divided by, how much you are getting here? This is divided by, this is divided by beta. What is the value of beta here? What is the value of beta here? Yes, please. What is the value of beta they are given? 100. Very good. 100. Correct. You are right. 100. Okay. Then calculate this. How much you are getting? 4.8 milliampere divided by 100. 4.8 into 10 raised to minus 3 divided by 100. So it will be how much? Can you tell me the answer?
4.8 into 10 raised to minus 5.
No. IC saturation is 4.8 into 10 raised to minus 3 divided by 100. How much you will get? Just see. See here.
4.8 into 10 raised to minus 5.
Minus 5. Okay, that is nothing but if you keep it in engineering mode, how much you get? 48 microampere. Right? 48 microampere. Am I right? 48 microampere you will get. Correct? So we got the value of IB max. Okay. Now we have to apply this condition. Condition is IB should be 120 to 150% of IB max. So let us take the highest value, that is 150. That is 150% of IB max. So for 100 it is 150%. Okay. For 150 divided by 100. 150 divided by 100. 150 divided by 100. Okay. This divided by 100. 50 divided by 100. 100 is 150%. Therefore, for what value you have to calculate? IB max. IB max is just now we have calculated 48 microampere. 48 microampere. Okay. It is 48 microampere. Substitute that. Then find the value of this. See how much you get IB. So for transistor to go to saturation, IB should be 150% of IB max. If you apply this condition, how much you get? IB value?
Sir, 7.2 into 10 raised to minus 4.
Very good. So it is 72 microampere. Keep it in engineering mode, your calci, so that you get 72 microampere. Just check 72 microampere. Correct? Am I right? Next, we have calculated IB. Then what is the equation to calculate RB? So if you want RB is in the input side. See the circuit. RB is in the input side. Yes or no? So you have to apply the KVL equation to the input loop. That we have already applied. Let us use that equation directly. The equation is for IB or RB Here we have written the equation for IB. Okay. IB equation. Here it is. IB is equal to V in minus VB by RB. IB is equal to V in minus VB by RB. So substitute all the values. 5 minus 0.7 volts. 5 minus 0.7 volts. This divided by RB. This divided by RB. Substitute the values. See how much you get. Just substitute the values. 5 minus 0.7 divided by RB. Just check how much you are getting. 5 minus 0.7 by RB. RB is how much? You have to calculate the value of RB. Okay. So this you have to rearrange for RB. So that means we will get here RB is equal to 5 minus 0.7 divided by this divided by IB. This divided by IB will get IB. So IB if you substitute, IB is how much? IB. So this divided by IB it is. If you rearrange this, you will get RB is equal to V minus VB by IB. So IB is how much, students? IB is how much you got previously? 22 microampere. 22 microampere. Okay. Then substitute that value here. 72 microampere. Okay. So if you 72 microampere, if you just substitute here, then how much you get? After substituting 72 is equal to 72 microampere here. Just find out the answer here. 5 minus 0.7. This divided by 72 microampere. Minus 0.7 is 4.3 volt divided by 72 microampere. How much you get? Tell me the answer. 5 minus 0.7 is
59.72 kilo ohm.
59.72 kilo ohm. Exactly. The answer is 59.7222 or 7.2 kilo ohms. 7.2 kilo ohms. So we got the value of RB. So value of RB is 59.72 kilo ohms. Okay. So this is how we will be finding the value of RB by using the equations under the transistor when it is in saturation condition. Clear here? All of you understood here this example? So such example may be asked in the examination. Are you clear with this example, students? This example is clear here? Yes, please. Example is clear here. All of you understood this example?
Yes, sir.
Okay, fine. Let us discuss the assignment questions. Assignment questions. See here the first question, that is double-ended clipper. Question number 1 and question number 2. That circuit, whatever is there, that notes I will share with you. Okay, question number 1 and question number 2. That assignment question, you can just have a copy of that in your hand right now. So question number 1 and question number 2 notes I will be sharing with you. Okay, I will share you the material on that. Then next is question number 3. Question number 3. Okay, question number 3. Write the procedure for analyzing the clamping circuit. Determine output voltage for the network shown in figure. Assuming F is equal to 1000 Hz and ideal diode. Look into that circuit. So it is the question number 3. Right, question number 3. That circuit you just see. Okay. So for that circuit, question number 3, it is a clamping circuit, right? That we have solved in class. Question number 3 we have solved in class. Okay. So that is the same thing what we are getting here. Okay. Next, the solved problem. Next, question number 4. Consider a fixed bias circuit of a transistor. Obtain expressions for stability factor S of ICO, S of VB, and S of beta. Draw the circuit diagram. That is also solved. Yes or no? Question number 4 is solved. Then question number 5. Question number 5. What is question number 5 here, students? What is question number 5? Yes. What is question number 5 here? Just see the question number 5. What is question number 5, students here? Question number 5. For the circuit shown in figure, find IC, VB, VE, RI, and S of ICO. Okay. So this is on the voltage divider bias circuit. On the voltage divider bias circuit. Okay. So that I will share with you. Material I will share with you. Have you solved that? Have you solved that, students? Question number this, have you solved that? Question number 5. Okay. Have you solved that, students? Voltage divider bus, have you tried that?
Yes, sir.
So what are the answers you are getting? Can you please tell me that? Answers.
Yes, sir.
Please tell me the answers.
So IC value is 1.276 milliampere.
Very good. Next, VB.
VB is 2.246 volt.
2.246. Correct. You are right.
246.
Next, what about VE?
1.54 volt.
Correct. Very good. Then what about R1?
R1 39.2. No, 39.28.
Excellent. What about S of ICO? Last one.
4.88.
4.885. Correct. Very good. Huh? You're done with that. Correct. Answers are right. So it's absolutely correct. Okay. So those who are not done, I will share with you the answers of that. Okay. Solution I will be sharing with you. Okay. Next is question number 6. Define operating point, explain its significance. Define operating point, explain its significance. So you have to define the operating point. To define the operating point there. Okay. To define the operating point, and then you have to explain its significance. Question number 6. Explain its significance. Operating point, how you are getting? If when you draw the load line, when it intersects the base current curve, you are getting the operating point. So what is the use of operating point? It can be used to find out the values of IC and VC and other parameters which are related to IC and VC. Is it not? So like that you have to explain the importance of the operating point. You have to write points about the operating point. Question number 7. Explain the different biasing circuits of BJT. For each circuit, find an expression for stability factor. Also describe how to find the Q point of the circuit. This is a quite large answer. So such questions may not be asked in examination, but in one of the question paper they have asked this question for 12 marks. Explain the different biasing circuits. First you have to explain all the biasing circuits of BJT. Okay, so for every circuit you have to find expression for stability factor. They are not mentioned which stability factor. You can take the first one, S of ICO. You can find out for each circuit, and also describe how to find the Q point of the circuit. How we are finding the Q point? That is nothing but the operating point. Then question number 8 is draw the circuit of voltage divider bias. Take the circuit parameters. They have mentioned the values here: VCC, R2, R1, RC, RE. Find Q point and terminal voltages. Transistor has beta equal to 100 and VB is equal to 0.7 volts. Okay, so this is the problem here. What is meant by terminal voltages? Can anybody tell me? Terminal voltages means what? Terminal voltages. We have studied the voltage divider bias circuit. Which are the two methods we have studied? One is the exact method, another one is the approximate method. Correct? So in the exact method, we are not checking that condition. Okay, what is that condition there? Beta RE. Okay, what is that? Beta RE is greater than or equal to 10 times R2. That condition we are not checking. Yes or no? For the exact method, but for the approximate method, we are checking that condition. Beta R is greater than or equal to 10 times R2. You can use any one of the methods. Either you can use exact method or approximate method. If you are using approximate method, first you have to check whether beta R is greater than or equal to 10 times R2. Only then you can apply the approximate method. Otherwise, you have to go for the exact method. Okay, so use the method here, exact method. So terminal voltages are nothing but the voltages at the terminal, that is VE, emitted terminal voltage. Then VB, base terminal voltage. VC, collector terminal voltage. So VE is given by IE into RE. Okay, where IE is IB plus IC. IE is IB plus IC. Then VB is nothing but VBE plus VE, because we know that VBE is VB minus VE. VBE is VB minus VE. Therefore, VB will be equal to VBE plus VE. And VC is VCC minus ICRC. Question there. I have already described that when taking the class, and I have also provided the notes on that. Just go through that. Okay, VC is given by VCC minus ICRC. Okay, so these are the equations for the terminal voltages, that is VE, VB, and VC. Next question, explain the operation of transistor as a switch and with the help of neat circuit diagram and waveforms. Also enumerate the design procedure. So this is not there for your, because I have covered just before to 2 classes this portion. So this portion I'm not keeping. Explain DC analysis of collector to base bias circuit. So this will take up collector to base bias circuit DC analysis. You have to provide DC analysis. You have to perform here. The next question is question number 11. That is also not there because it is miscellaneous bias. Such question may not be. I mean, it's not there for your syllabus. Okay, miscellaneous bias they are not mentioned in the syllabus. That is question number 11. Then question number 12 for the emitter stabilized bias circuit, VCC is 10 volt, RC is 1 kilo ohm, RE is 500 ohm, RB is 100 kilo ohm, beta is 100. Calculate IB, IC, VCE, VE and VC. Draw the circuit diagram, find Q point and stability factor. Okay, so for the emitter stabilized bias circuit, okay, for the emitter stabilized bias circuit, you have to find out the values of IB, IC, VCE, VE and VC. You have to draw the circuit diagram of emitter stabilized bias circuit and you have to find the Q point and stability factor also. Q point is VCE and IC that you are finding in the first part of the problem itself, that is IB, IC, VC, VE and VC. Along with that you have to find out IC, IC also you are finding out. Stability factor you have to find out. Equation for stability factor that you have to use for the emitter stabilized bias circuit and you have to find out that. Okay. So IB equation is VCC minus, that is VCC minus VBE will get. Okay. Then IB is VCC minus VB divided by RB plus 1 plus beta into RE. That is the equation for emitter stabilized bias circuit. Is it not? IB equation VCC minus VBE divided by RB plus 1 plus beta into RE. Once you find out IB, then you can find out IC. IC is equal to beta into IB. Then VCE is given by VCC minus IC multiplied by RC plus R. VC is equal to VCC minus IC into RC plus RE. Once you find out VCE, then you can find out VE because VE is equal to IE into RE. IE into RE, that is I is IB plus IC into RE. So once you are finding VE, you also find out VC. VC is VCC minus IC into RC. These equations are already explained when explaining the emitter stabilized bias circuit. Also notes are provided on that. Just go through those equations and accordingly you have to substitute those values and you have to find out the different parameters. That is IB, IC, VCE, VE and VC. Okay. So in all these examples, whatever they are asking in examination, you have to know the formulas. You have to know how you are getting the formulas. You are applying the KVL equation to the input loop, KVL equation to the output loop. Accordingly, you have to get the equations or remember the equations. Better to remember the equations because it takes more time to do the analysis there. If you go on applying the KVL equation to input loop and output loop, just you have to know that how you are getting the equations. But if you go on applying the equations there and trying to get the equations, it will take more time. So better to remember the equations. Okay. So use the available equations, substitute the values, given values, and find out the values of the unknown. Next, question number 13 for a voltage divider bias circuit. RC is given, RE is given, R1 and R2 are given, beta is given. Determine the stability factor S of ICO. Draw the circuit diagram. You have to draw the circuit diagram of voltage divider bias circuit. Yes, what is the equation for S of ICO for voltage divider bias circuit? S of ICO equation for voltage divider bias circuit. It is 1 plus beta the whole divided by 1 plus beta RE divided by RE plus RB. S of ICO equation for voltage divider circuit is S of ICO is equal to 1 plus beta the whole divided by 1 plus beta RE by RE plus RB. Okay. Now in this equation we don't know the value of RB. You have to calculate the value of RB here for the voltage divider bias circuit. For the voltage divider bias circuit, RB is given by parallel combination of R1 and R2. RB is equal to R1 parallel R2. So once you know the value of RB, just substitute in the formula for S of ICO, then you will get the stability factor S of ICO for the voltage divider bias circuit. That is S of ICO is 1 plus beta divided by 1 plus beta RE divided by RE plus RB. Okay, use that equation. Question number 14, that is just we have discussed that saturation or condition of the transistor that I am not keeping. Then with the neat circuit diagram, explain emitter stabilized bias circuit, write the necessary equation. So emitter stabilized bias circuit you have to explain by considering the equations. Then question number 16 is also the same. It's already solved problem. Determine output voltage for the circuit. Assume F is equal to 1000 Hz and ideal diode. Okay, that we have also discussed in class. It's a solved problem in class. So transistor as an inverter, this I am not keeping. Question number 17. And question number 18, sketch the output waveform for the network. Question number 18 is, it's a solved example in the class. Instead of asking as 3 volts, okay, in class I have solved it for 10 volts. Peak value of the AC input is 10 volts we have taken input voltage. I mean, the voltage of DC supply voltage we have taken 10 volts in the class. But for that circuit, we will be here in the example, what we have asked is they are given 3 volts DC supply voltage. Okay, that is the only difference. It's a solved problem in class. Okay, question number 18. And question number 19, draw and explain the working of clamper circuit which clamps the positive peak of a signal to 0. Okay, so it's a design, draw and explain the working of clamper circuit which clamps the positive peak of a signal to 0. This is also solved in class. So solved question. What is meant by clamps the positive peak of a signal to 0, whether it is positive clamper or negative clamper? Yes. What they have asked is clamps the positive peak of a signal to 0, whether it is positive clamper or negative clamper. It is negative clamper, because positive clamper is 0, it is clamping positive peak to 0, you are getting the clamping in the negative side, correct? Peak to peak voltage you are getting in the negative side. Positive peak is completely 0, so it is negative clamper. This is solved question in the class, just refer to that. Negative clamper circuit, it's the beginning of the clamper. That question, it is answer to that is that part of the syllabus. Then question number 20, derive an expression for ETH, IB and VC for voltage divider bias circuit using exact analysis. Using exact analysis, you have to find out expression for ETH, IB and VCE for the voltage divider bias circuit. Okay, there are 2 methods as I told. One is exact method, another one is the approximate method. Next, question number 21, for the emitter bias network, whatever is given. So they are asking IB, IC, VC, VC, VE, VB and VBC. That's also solved problem in class. Is it not? Emitter bias network, solved problem. It's just refer to that problem. It's a solved example in class. Next, question number 22, what is biasing? Discuss the factors that causes or bias instability in a transistor. So question number 22. So what is biasing? First you have to explain that. Biasing means you are applying the voltage input to the circuit, okay, so as to make the transistor to operate in a particular region. Usually transistor is operated in the active region or the linear region. Okay, so that part you have to explain. Then next what you have to explain is which causes bias instability. Bias instability, this is caused by variation in temperature. As temperature doubles, sorry, as temperature increases by 10 degrees Celsius, the collector current doubles. Okay, then as the temperature changes, as the temperature increases by 1 degree Celsius, VBE, base to emitter voltage, decreases by 2.5 millivolts. Okay, that is another instability condition. Then as the temperature increases, beta also increases. So you have to explain how the temperature change will affect the value of IC, that is by change of the value of ICEO, collector leakage current, beta, and then the beta and then VBE. Okay, so these are the factors which causes the bias instability in a transistor. Then plot the transfer characteristics for the circuit shown in figure. That part I will provide the notes on that material. I will provide. Sketch the output voltage. This is just some data is missing there. Okay, that part I will not ask. Question number 25. Determine the levels of ICQ and VCEQ for the voltage divider configuration using the exact and approximate techniques. Use VCC is equal to 18 volts, R1 is equal to 82K, R2 is 22K, RC 5.6, RE 1.2K and beta equal to 50. So I have shared the notes on this particular example. Notes are being shared with you all. Okay, and I have also explained how to perform the exact method and how to apply the approximate technique for the voltage divider bias circuit. Okay, it's a solved example in class. Just refer to the notes. Okay. So this is all about the assignment questions, friends. You want to ask anything here? You want to ask anything? Students? You want to ask anything about the test? Any other things you want to ask? Janvi, you want to ask anything? Janvi? 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 Mahadev? Mahadev? Kirti? Kirti? Ankita? Ankita?
Yes, sir.
You want to ask anything, Ankita?
No, sir. Nothing.
Please, if you have any doubts, anything, just ask.
No, sir. Nothing.
Okay. You are clear with the assignment questions right now?
Yes, sir.
Okay,
Yes,
fine. Okay. If you have any doubts, anything to ask, any problem in understanding, you can just ask me.
Okay, sir.
Okay. Prajwal Gowda? Prajwal Gowda? Ratan? Ratan? Ratan Birje? You want to ask anything? Ratan? Rutik? Rutik? Sadashiv Gari? You want to ask anything? Sadashiv? Sadashiv? Kaji? Samir Ahmad?
No, sir.
Anything you want to ask about the test or about the assignment questions or about the today's class? Any difficulty, Samir Ahmad?
No, sir.
Hmm? Clear with it, right? Everything?
Yes, sir.
Okay, fine. Sanket, any difficulty? Sanket? Sanket? Shiraj? So clear with it, right? Yes, please. Clear with it, right? Today's topics, what all we discussed. Clear with it. You want to ask anything else? You want to ask anything else, students? Yes, please.
Sir,
Ankita, you want to ask anything else apart from this? Or shall we wind up?
No doubt,
Ankita?
sir.
No doubts, no?
Nothing.
Okay, fine. Okay,
Yes.
fine. Do well. Wish you all the best. Work hard. Okay? Right.
Okay, sir.
Okay, thank you.